6? 2 to the 6 equals 54? Very good. How'd you do it? Just plug in code. There you go. And that's what you would have had to do unless you could use what we're going to learn today. You could use logarithms to solve this problem without having to guess. Because you might have one that looks much harder than this one, like 1.7 to the x equals some ginormous decimal, and you'd have nowhere to even start. Not to mention, all that you're doing right now is in the hope that this is just a nice whole number. What if this had been something like 120? Then it would have to be some decimal would give you that. So a way to do this is fundamental rule of algebra. Whatever you do to one side of an equation, you have to do to the other. Same thing. If you log one side, you just log the other. Now, how do you think logging both sides is going to help me? What happens to the x?
It's going to be like the x will.
That's right. The x will come down. Now you have x log of 2 equals log 64. That's right, just divide. X would equal log 64 over log of 2, which is 6 if you punch it into your calculator. And that's what we're doing today. We're going to solve exponential equations by using logarithms. Yay, doesn't that sound awesome? Okay, first slide. Boom, and there's only 2 slides, so there's half the slide. This is 3.4, which I've broken down into 2 sections. Second half we'll do tomorrow. 3.4. Essentially, you're just going to be taking the log of both sides every time you see a variable in the exponent. So, every problem. You could take natural log too. I think the book in their examples show natural log. It doesn't matter. They're the same thing. And since we're not using a base for any of them, then it doesn't matter which one you use. I've mentioned it a few times. Not that it matters for this class, but can anybody tell me what the difference was between log and natural log?
Log has a base of 10 and natural log has a base of 2.
Got it. Very good. You know when you want to take your test, Nick?
I can't believe I knew that.
You know when you want to take your test? Okay. Well, you might want to look over that stuff and maybe give it to you the next day or two. Oh, thank you. What? Oh, thank you. All right. So, moving on. Every single one of these can be done the same way. Let's look at number 5.
Number 1, 2.
So you take the log of both sides. So that would be log here, log here. The whole purpose of doing that is to use the power rule. So this comes down and is now 2x minus 1 log of 2 equals log of 32. Divide.
So there's like no way you can do this.
I guess you could, but it'd be hard. What?
Well, how are you going to know what the log is doing all the things?
Yeah, well, yeah, you'd have to use calculator for that. What'd you say? Well, because imagine we had 3x and minus 1 and 2 and 4. You divide the 2 to solve for this, so same difference. Yes, then you just add the 1, divide by the 2, and what do you get? 3? Very good. X equals 3. Now, technically, what they really wanted you to do for as many of these as you could would to just be to notice, hey, 2 to the x, can you write 64 as 2 to the something? Yes, you could. That's 2, what did we just say? What comes on to the 6? And you could do it just using common basis for some of these, but I say just cut out that and just use logs. It's easier. Look at this screen. What's another one somebody would like to see?
Number 19.
Let me look at number 15 for just a second, and I'll tell you why. How could I rewrite the part on the right?
You can do 1/2 log squared.
Well, this is the same thing as 6 to the 1/2, right? Whenever you have the same base, see how these have the same base? Well, then all you have to do is set the exponents equal. So if they give you one where you have the same base, like this is e to the negative 1, I don't think there's any others actually.
So I just 5.
So 6 to the 1/2 equal, well, you could just set those two equal. 1/2 equals this. Let's just do that real quick. For number 15. And of course you could do it the same way. You could go ahead and do the logs and everything, but you're eventually just going to be doing this anyway, because log 6 over log 6 is just going to cancel. So x minus 3 over 4 equals 1/2. Multiply by 4. Yes, you were right. I don't know about that. Add 3, and yes, x would be 5 for that problem. But all the rest of these you can use logarithms on. And does somebody have one they'd like to see? I'm glad you asked about 19. No, it is a little different. No, you didn't. I just didn't hear you. 19 is a little different. Just because, well, what makes it different? Well, there's no log on any of them. You have to put in the log. Well, the bases are only the same on one or two of them. What makes this one different is that there's a variable in both exponents. But when you log both sides, it's going to turn out very similarly. So that's bring down the x plus 3, so that's log of 8, x minus 1, log of 16. Now, this is where it gets a tad tricky. Make sure you're paying attention. No. What? Who asked me a question? Never mind. No? Okay. You want to distribute. When you distribute, you get x log 8 plus 3 log 8 equals x log 16 minus 1 log 16. Before I go any further, are there questions about where either of those steps has come from? No?
I reckon not.
Good. Move the x's to one side, non-x's to the other. So I'm going to bring this one over to this side. So that'll be x log 8 minus x log 16. And I'm going to bring this one over to that side. So that'll be negative 3 log 8 minus log 16. Whoa. Excuse me. I don't know. That's true. That's true. Okay, before I go any further, are there questions about how we got from the second step to the third step? I just subtracted this over there and subtracted this over here, so I have the x's on one side, non-x's on the other. Questions? No? What factors out of the left? X. So you're left with x log 8 minus log 16. Almost. Well, yeah, you could go ahead and punch it all in to get numbers, but I'll show you how to do it in one step. So that's negative 3 log 8 minus log 16. Now remember, just like trig functions, logs, those are all going to give you numbers, like Adam said. So just divide it all, and you get x equals negative 3 log 8 minus log 16 divided by that quantity, hold on, let me get mine, divided by the quantity log 8 minus log 16. All I did was divide that whole parentheses section, and that you can punch into the calculator. No. Good question. No, I didn't. This subtraction I didn't do anything with. I'm dividing because this is being multiplied. Hold on. I want to plug it in. Okay, so parentheses for the numerator. Negative 3 log 8 close minus log 16 close the numerator divided by log of 8 minus log of 16, and it is 13 when you punch it in the calculator. Probably a parentheses issue. No. The second insert. Do you know how to bring up your entire equation again? Yeah, if you hit second enter, it brings up everything you had just typed in, like that. And then you can hit second delete and insert things wherever you want them, so you don't have to retype everything. Questions about how we solve that. That's going to come up whenever you have x's in both exponents. Question? No? Braden, are you as excited as you look? You're like, yeah, log! Woo! Party time. Okay. Any other problems on this slide you'd like to see work? Doesn't matter. But 21, if you rewrote it, that'd be e to the x plus 1 equals e to the negative 1, and you could just set those two equal if you wanted to. Or you could just, it wouldn't matter. Natural log makes more sense, obviously, but you don't have to. 1 over anything, well, that's something we talked about a few days ago, a way to exponents. You know, there's the normal number exponents, fractions give you roots, and negative exponents like 2 to the negative 2 is the same as 1 over 2 squared. A negative exponent just flips to the denominator. So like if I had 1 over x cubed, that's the same as x to the negative 3. Sure. Okay. Any further questions about this slide? Pick one. 13. Actually, hold on a second. No, never mind. That was what I was. Well, no, you'd have to set them equal. X plus 1 equals negative 1. Yeah. And once you have a common base, just set the exponents equal. What'd you say? Well, there's really nothing more to do there. I guess I could do it the other way. Would you want me to do it the other way? Sure, let's do 21, but let's do it without using the common basis thing, just in case you didn't notice that that is the same as e to the negative 1. So, let's log both sides, right? That's pretty much going to be your first trick every time. So, log of both sides, x plus 1 is going to come down. So that's log of e equals 1, log of 1 over e. Divide. And then subtract 1, and you're done. Well, because these are being multiplied. So, only time you will need to distribute like I did in the last problem is if there's an x on both sides. When there's not, you can just divide away the nuisances. So that's ready to go into the old calculadora. And I'm hoping it's negative 2, because that's what we already found once. So, thank you. Log of 1 over e is, where is e? It's right above, oh yeah, there it is, thank you. It's right above the division sign. So 1 over e divided by log of e. It's just a number, it's like pi, except it's used more in physics. Yeah. No. No, e is just a number, so just treat it like a number. Like a pi. So, that's negative 1 minus 1 did equal negative 2. So, yeah, if you have a common base, you can set the exponents equal. Okay. Adam, was that good? Alrighty. Anybody need me to leave this on this slide for a moment? Okay. Last slide. But it's actually the same exact thing. The exact same thing. Obviously, the ones on the right are a little different. We'll look at those in a second. But, yeah, all of these are going to work the same way. Let's look at, I don't know. Pick one on the left side you want to see. 31's first thing I heard. 31. Just like the last slide, our first step every time is going to be to log everything. We sound like an accountant. No? Nobody? Okay. Cool. Thank you. You don't think I realized that? Alright, bring down the 5x because it's an exponent. And then you're right back to what we were a second ago. 5x equals log of 1977 over log of 3e. You're going to punch all that in your calculator, then just divide it by 5. And you'll have x solved for. If somebody wants to finish that up and tell me the answer, they can, but I'm just really interested in if you guys see what to do from here. You'll punch that in the calculator, then divide it by 5, and you're done. Questions about this one? Thank you. 3.616. That's not what you got? Well, let's see what I get. I'll be the tiebreaker. I won't. Log 1977 divided by log of 3. You forgot to divide it by 5. It's equal to 5x. Divide by 5, 0.72-ish.
You're wrong.
Anyway, technically you were 5 times right. What? Oh, it'll probably stay in the directions. Just kidding. In the directions it says for 2 decimal places. All right. Is there anything on the left-hand side somebody wants to see?
No.
Right-hand side. Well, the top 2 are just like the ones we just did. The top 2 are just like the ones we just did. The bottom 3 are a tad different, obviously. But 39, 41, does somebody want to see one of those? We sure? 41, good idea. Let's look at 41. Probably today, if any day. I doubt they'll come back to the reunion in 10 years and say thank you for asking for number 41. But I challenge someone to do that. That would be hilarious. Okay. All right. Log both sides so that the exponents can come down. Braden, what do you think I'm going to do from here? There is a right answer to this question. That's exactly what we're going to do. So you get 2x log 5 plus 3 log 5, x log 3 minus log 3. Now what are we going to do? Are we? Right. We're going to put the x's on the same side. So that's 2x log 5. Bring over the other one. Bring that one over. Now from here, you just factor out the x. Boy, these get a little tedious, don't they? Anyway, from there you just divide and you're done. Okay?
Sounds good.
Fine. Questions about these before we move on? Nope. All right. All right. These you have to factor. Oh no. Yes. You have to factor these. Is it worth it? Is it worth it? Well, let me just show you how you would do it. I won't make you do one, but this is all you would have had to do, like 47. People look at these and they think, well, let me ask you this. What is x times x? That's right. It's x squared. What do you think x to the x times x to the x is? Yes, it's x to the 2x. By that same rationale, this is going to factor just like normal stuff, except instead of just x, it'll be 3x, 3x. Because when you, oh, actually that's not true, it'll be radical 3x. So when you square those, you get 3, x to the 2x, and blah, blah, blah. I'm not going to make you do that, though. So, anywho, there you go. Yeah, go ahead and do yesterday's bonus or review and today's. There's only 7 problems in the top part. 7. Yes. That's up to you. You don't have to. Your 2 things to do today are to finish yesterday's review and to do this. You can do them on the same sheet if you want to, but you don't have to. Yeah. Remember, yesterday's was 3.3, today's is 3.4. What? Not today.